limit x tends to 0, x into e raised to x minus log of 1 plus x upon x square. Okay. Now this is the limit which is given to you. We will evaluate its value. First of all, whenever the limits problems are given to you, then identify the form of the limit. It is given in which form? Either it is 0 by 0 or infinity by infinity or 0 into infinity or infinity minus infinity. Okay. So we will identify by substituting the limit. See that limit x tends to 0. So here x to 0. So putting the value of x is equal to 0 in the limit, what we get here? If you put x is equal to 0, so this becomes 0 into e raised to 0 minus log of 1 plus 0 upon 0 square. But 0 into e raised to 0 is 1. 1 into 0 is 0 minus log of 1, that is also 0 upon 0. So 0 minus 0, that is 0 divided by 0. So given example is now in 0 by 0 form. Okay. Given problem is in 0 by 0 form. So we will write here, this is the 0 by 0 form. Now how to solve this problem which is in 0 by 0 form? So we will apply derivative on numerator as well as denominator using L'Hospital rule. Okay. So by L'Hospital rule, I will write in short, by L'Hospital rule, we will differentiate the numerator as well as denominator function with respect to x. So as x tends to 0, taking derivative of numerator function, for each term we will differentiate this. So x into e raised to x, this is the first term of numerator, minus d by dx of second term, that is log of 1 plus x, okay, divided by d by dx of x square. Differentiate the numerator function as well as denominator function with respect to x. So taking derivative of each and every term with respect to x. Now see here, limit x tends to 0 of. Now derivative of this x e raised to x with respect to x. See here, we will apply product and differentiate this with respect to x because there are two functions of x. One is x, another is e raised to x. So here, u into v rule. What is u into v rule? That is u into v dash plus v into u dash. Derivative. U dash means a derivative. So if you differentiate this d by dx of x into e raised to x, first function u is x and v is equal to e raised to x. So what will be the derivative? U into v dash. U is x into v dash, derivative of e raised to x with respect to x, that is d by dx of e raised to x, plus v, that is e raised to x, into d by dx of u, that is x. Now find out the derivative x, derivative of e raised to x, that is same, e raised to x, plus e raised to x into derivative of x with respect to x, that is 1. So you will write here this value d by dx of x e raised to x as x into e raised to x plus e raised to x into 1 minus. Now derivative of log of 1 plus x. Log function, its derivative, that is 1 upon 1 plus x. Okay. Derivative of log of 1 plus x, that is 1 upon 1 plus x into derivative of 1 plus x with respect to x. For 1 it is 0 and for x it is 1. Okay. Divided by d by dx of x square. What is derivative of x square? That is 2x. Derivative of x square is 2x. Now we will rewrite this as limit x tends to 0. Limit x tends to 0. X e raised to x. This is the first term. Plus e raised to x minus 1 upon 1 plus x divided by 2x. Now, if you put x is equal to 0 in this, then what will happen? If you put x is equal to 0, this becomes 0 into e raised to 0. E raised to 0 is 1 into 0 plus e raised to 0, that is 1, minus 1 upon 1 plus 0 divided by 2 into 0. Okay. Now see here, e raised to 0 is 1, 1 into 0 is 0, plus again e raised to 0 is 1, and 1 upon 1, that is again 1 with minus sign. Divide by 2 into 0 is 0, 1 1 they cancel. So So again it is in 0 by 0 form. Okay. By applying limit in the derivative, first derivative, here it is again in 0 by 0 form. This occur in again 0 by 0 form. So here again we will apply the L'Hospital rule. So here we get the f dash x function upon g dash x. So we will differentiate this again with respect to x, because by applying x is equal to 0, x tends to 0. By applying this limit x tends to 0, our function is indeterminate form, that is in 0 by 0 form. So again, to get limit, we will differentiate this function with respect to x. Okay. So here we will differentiate the function x with respect to x. What we get? Again applying L'Hospital rule. Again using L'Hospital rule. Differentiating this with respect to x. So it is limit x tends to 0 of, differentiate this numerator function with respect to x, denominator function with respect to x. So what is d by dx? D by dx of x into e raised to x plus, now there are 3 terms in numerator. See here, there are 3 terms in numerator. So we will differentiate each and every term with respect to x. Okay, plus d by dx of e raised to x minus d by dx of 1 upon 1 plus x divided by d by dx of 2x, derivative of denominator function. So taking derivative of numerator function as well as denominator function. Now see here, already we have find out the derivative of x into e raised to x. Already here we have find out the derivative, that is x into e raised to x plus e raised to x. So this is the derivative of first term, x e raised to x plus e raised to x, plus derivative of this term e raised to x, same e raised to x, minus, now d by dx of 1 upon 1 plus x. 1 upon 1 plus x, for derivative of 1 upon 1 plus x, its derivative, we know that d by dx of 1 by x. This derivative of 1 by x, this is minus 1 by x square. So according to that, derivative of 1 upon 1 plus x will be minus 1 upon 1 plus x whole bracket square. Okay, minus 1 upon 1 plus x whole bracket square into d by dx of 1 plus x, that is 0 plus 1, that is multiplied by 1. And whole term is divided by d by dx of 2x with respect to x, that is only 2. Okay, and now in this derivative we will apply the limit. Now putting x is equal to 0, by applying limit, put x is equal to 0. So 0 into e raised to 0 plus, this is e raised to 0 plus, this is e raised to 0, minus minus become plus, 1 upon 1 plus 0 divided by 2. And now carry out this calculation. So 0 into e raised to 0 is 1. Since we know that e raised to 0 is 1, so this value is 1 into 0, that is 0, plus e raised to 0 is 1, plus again e raised to 0 is 1, plus 1 upon 1, that is 1, divided by 2. So 1 plus 1, that is 3 by 2, and 3 by 2 is the limit of the given function. So L is equal to 3 by 2. This is the limit which is finite number. So this is the limit of the given example, which is in 0 by 0 form. So in this way we can evaluate the limit when the function is in 0 by 0 form. Applying L'Hospital rule, apply the limit. If in the derivative, after applying limit, it is in 0 by 0 form, it is not finite, then use the same procedure till you will get the finite limit. Okay? So in this way we can find out the limit. Then the second case is in 0 by 0 form. Second case is if in the limit there is some constant, then we will evaluate the value of that constant also, and with the help of that constant we can determine the limit of the given function. So whenever constant is involved in the limit, how to find out the value of that constant and how to evaluate the limit. So we will consider that case. Question is, if limit sine 2x plus p sine x, if limit x tends to 0, sine 2x plus p sine p, it is sine x upon x cube, p sine x upon x raised to 3 is finite, then find the value of p and hence evaluate the limit. This is finite. Limit is finite. This is given to you. Limit is finite. Then find the p value and hence evaluate the limit. We will find out the first p value and using that p we can evaluate the limit. Now see here, if you assume L is the limit of this function sine 2x plus p sine x upon x cube. P is constant here, so in the first step we will determine the value of p, and with the help of this p we can evaluate the limit L. Okay. Now see here, sine 2x can be written as 2 sine x into cos x. Sine 2 theta is 2 sine theta into cos theta. So according to that, we can write this as sine 2x 2 sine x into cos x plus this p sine x as it is divided by x raised to 3. Now sine x is present in numerator in both the terms, so we will take this value as common. So we take sine x common, in bracket we get 2 cos of x plus p divided by, we split this x raised to 3 as x into x square. Okay, we split this x raised to 3 as x into x square. Now we separate the limits. So taking separately limit for this sin x upon x, separate the limit, multiply by another function for its limit is 2 cos of x plus p upon x square. So apply the limit separately for the two terms. For sin x upon x, apply the limit x tends to 0, sin x upon x, and another for this second term, multiply by limit of 2 cos of x plus p upon x square. Now we know that this is the standard result. Limit of sin x upon x as x tends to 0 is always 1. Okay, so this is 1 multiply by limit of x tends to 0, 2 cos of x plus p upon x square. As we know that limit sin x upon x as x tends to 0, this is 1. So we get only limit of the second term, that is 2 cos x plus p upon x square. Okay, so here to evaluate the value of p, what is given here? This limit of this function is finite. So when we get finite limit, when it is in 0 by 0 form. So when we apply limit here in the numerator as well as denominator of this function, see here, L is equal to limit x tends to 0 of numerator function 2 cos x plus p upon x square. Now see, if you apply limit x is equal to 0, what will happen? We get 2 into cos of 0 plus p upon x is equal to 0. Now numerator value. See the numerator, cos 0 value is 1. We know that cos of 0 is 1. So this becomes 2 plus p upon 0. Okay. When we apply limit in the second function, then it becomes 2 cos of 0 plus p upon 0. But cos 0 is 1, so this is only 2 plus p upon 0. But limit is finite, this is given to you. So if it is finite, then numerator must tends to 0 because it is in 0 by 0 form. Then only it is finite. Okay, so we will apply. We will equate this 2 plus p with 0. Equating the numerator with 0. If it is in 0 by 0 form, then only you will get a finite limit. So equate the numerator with 0. So we will equate this 2 plus p with 0. So value of p is equal to minus 2. We get p is equal to minus 2. So this is the first part. in which we calculate the value of constant, that is. Now using this value of p, in the second part we will find out the limit. Okay, with the help of this p, evaluating the limit. Now if we assume this is our equation number 1, then in equation 1 put the value of p as -2. Okay, to get limit L, putting the value of p -2 in equation 1, so this becomes 2 cos of x minus plus p is -2, that becomes -2 divided by x squared. Now see the form of the function. See, if you apply the limit x tends to 0, then this becomes 2 into cos of 0 minus 2 upon 0. But cos 0 is 1, so this is 2 minus 2 upon 0. 2 minus 2 is 0, and it is denominator is 0, so it is in 0 by 0 form. So given limit of the function is in 0 by 0 form, therefore now we will apply L'Hospital rule. Okay? Therefore by the L'Hospital rule, we will differentiate the numerator function as well as denominator function. This function 2 cos x minus 2 upon x squared. So taking derivative of this numerator and denominator function with respect to x, because by applying limit x tends to 0, the limit of the function becomes indeterminate, that is in 0 by 0 form. So here we will apply the limit. Okay, so apply limit, take the derivative of numerator and denominator function. So this is equal to, L is equal to limit x tends to 0 of d by dx of 2 cos x minus d by dx of 2 divided by d by dx of x squared. Take the derivative of each and every term. So limit x tends to 0. 2 into derivative of cos x is minus sin x. 2 is constant, derivative of cos x minus sin x, minus derivative of this constant 2, that is 0, divided by derivative of x square, that is 2x. Now see here, 2 and 2 get cancelled with each other. Constant is -1, take outside the limit. We will take constant outside the limit. So limit x tends to 0, we get sin x upon x. And now we know that again limit of the sin x upon x is 1. So 1 into -1. So answer is -1. So L is equal to -1 is the value of limit. Okay. So in this way, in this problem, we find the value of constant p, and with the help of that constant p, we find out the limit L. L is equal to -1 and p is equal to -2. This is the answer. Okay. Again, we will solve one more example on this constant. Yes. To find the values of two constants a and b, find the values of two constants a and b. If limit x tends to 0 of sin x into x raised to -3, limit x tends to 0, x raised to -3 into sin x plus a x raised to -2 plus b, a x raised to -2 plus b equal to 0, equal to 0. So this is given to you. Limit of this function is given to you, in which a and b are constant, and here we have to determine only the values of constant. What will be the values of a and b, such that limit of this function is finite and this is given as 0. Try to solve this problem. We can write this x raised to -3 as, if you shift this term in denominator, that becomes x raised to 3. So we can write this given limit in this form also, that is x tends to 0, sin x plus sin x upon x raised to 3 plus a upon x raised to 2 plus b is equal to 0. So this is the given function. So here you can take LCM. What will be the LCM for this function? LCM will be x raised to 3. LCM is x raised to 3. See here, we will multiply this term by 1, here by x, and for b, it is b by 1, that is x raised to 3. So if you take LCM as x raised to 3, this function can be written as limit x tends to 0. Multiply sin x by 1, so it is sin x only, plus x into ax plus b into x raised to 3. Okay. So as a math, this is the function sin x plus ax plus bx cube divided by x raised to 3. Now, if you apply the limit in this form, then see the form of the function by applying limit. Here we get sin 0 plus x is 0. So 0 into a plus b into 0 cube divided by 0. Sin 0 is 0 value. 0 plus 0 plus 0, that is 0. Divided by 0 cube, that is 0. So it is in 0 by 0 form. Okay. So if it is in 0 by 0 form, you can apply L'Hospital rule. Okay. So by using L'Hospital rule, we will differentiate the numerator and denominator function with respect to x. Okay. d by dx of sin x plus d by dx of ax plus d by dx of bx raised to 3 divided by d by dx of x raised to 3. So differentiating each and every term of numerator and denominator with respect to x. Find out the derivative. Limit x tends to 0. d by dx of sin x, that is cos of x, plus d by dx of x with respect to x. Derivative of x with respect to x is only a. A is constant, a into 1, that is a, plus a, plus derivative of this bx with respect to x. So derivative of only x raised to 3, that is 3x square into b. 3x square into b divided by 3x square. Now, if you apply the limit, by applying limit, as x tends to 0, what will happen? This becomes cos of 0 plus a plus cos of 0 plus a, this is constant value, 3 into 0 square plus b, that is 0, divided by 3 into 0, that is 0. So here in numerator we get non-zero term, cos 0 is 1, so 1 plus a upon 0. We get such a type of form, 1 plus a upon 0. Now what is given? Limit of this function is given as 0. Limit of this function is given as 0, that is finite, and when we get finite limit, when it is in 0 by 0 form. So we will equate this numerator with 0, equating this numerator with 0. So what is the numerator? 1 plus a. Equate it with 0, we get value of a as minus 1. Okay? A is equal to minus 1. So we get value of first constant a as minus 1. Now if this is our equation number 1, then in this equation we will substitute the value of a as minus 1. Okay? Yes. Putting the value of a as minus 1 in equation 1, we get L is equal to limit x tends to 0 of cos of x minus 1 plus 3x square b divided by 3x square. So put the value of a, value of first constant in equation number 1. Now it is, again if you apply the limit, see the form. If you put x is equal to 0, this becomes cos of 0 minus 1 plus 3 into 0 upon 0. So cos 0 is 1, 1 minus 1 upon 0. They both get cancelled. So again your form is 0 by 0 form. Okay. So if your form is 0 by 0 form, again we will apply L'Hospital rule. So we differentiate this function with respect to x, numerator function as well as denominator function. So differentiating this function with respect to x, because by putting x is equal to 0, we get 0 by 0 form. We will apply L'Hospital rule, therefore L become limit x tends to 0 of d by dx of cos x minus d by dx of 1 plus d by dx of 3x square b upon d by dx of 3x square. Differentiating each and every term with respect to x. So derivative of cos x is minus sin x, its limit x tends to 0, minus sin x, derivative of constant is 0, derivative of 3x square, that is 6x b upon 3 into 0. Derivative of this, that is 6x. Okay. d by dx of 3x square, 6x. Now see here, if you apply again limit, sin 0 is 0, this is 0, again this is 0. So by applying limit, denominator and numerator both become 0. So again we will apply L'Hospital rule. We will repeat the same procedure till there is finite limit. So derivative of sin x again minus cos of x plus derivative of 6x with respect to x, 6 multiplied by b, derivative of 6x with respect to 6. And now if you put x is equal to 0, this becomes minus cos of 0 is 1, minus 1 plus 6b upon 6 is equal to what? L. But this L limit is given as 0. This is given in the problem. L is equal to 0. Limit is given to you. L is equal to 0. This is given to you. But L is 0. So equate this value 1 plus 6b upon 6 with 0. Equating this right hand side with 0, we get value of b as. Okay. We will equate the right hand side, that is minus 1 plus 6b upon 6 with 0, because limit 0 is given to you. So 6b minus 1 upon 6 is equal to 0. Equate this with 0. So simplify this. So 6b minus 1 is equal to 0 into 6, that is 0. 6b is equal to 1, or this implies b is equal to 1 by 6. Okay. So this is the value of second constant, b is equal to 1 by 6. In this way, in the second type of 0 by 0 form, we can evaluate the value of constant as well as we can evaluate the limit. So these are the problems of the second type. Now, the first form is 0 by 0 form. Now the second form is infinity by infinity form. This can be solved similar as 0 by 0 form. Problems of infinity by infinity form can be solved in similar way. Okay. The second form is infinity by infinity form. How to identify? Applying limit in the function. If limit of the function fx upon gx as x tends to some value a. So this is infinity by infinity. Then if it is infinity by infinity, then directly we will apply the L'Hospital rule. We will differentiate the numerator and denominator with respect to x. Find out f dash x as well as g dash x. Then apply the limit. If limit is finite, then it is answer. If it is again infinity by infinity form, then again use the L'Hospital rule. Okay. So same procedure is there. Consider example on this infinity by infinity form. Question is limit theta tends to pi by 2. Limit theta tends to pi by 2 of log of theta minus pi by 2 upon tan theta. Log of theta minus pi by 2 upon tan theta. Now first of all, we will check the form of the function. Okay. By putting the value of theta. See here, function is null, numerator and denominator is the function of theta and limit is theta tends to pi by 2. So if you put the value of theta as pi by 2 in this numerator and denominator function, this becomes log of pi by 2 minus pi by 2 divided by tan pi by 2. Substitute the value of theta as pi by 2. So this becomes pi by 2 get cancelled. This is log of 0 divided by tan pi by 2, that is infinity. Log of 0 is infinity. So this is now in infinity by infinity form. So first of all, we identify the form of the given function. So this function is now in infinity by infinity form. So this is our infinity by infinity form. So we will apply L'Hospital rule. Therefore, by using L'Hospital rule, we will differentiate the numerator and denominator with respect to theta. Okay. Because function is function of theta, denominator and numerator function is function of theta. So it is d by d theta of log of theta minus pi by 2 divided by d by d theta of tan theta. Take the derivative of numerator and denominator function with respect to theta. Okay. So this is equal to limit theta tends to pi by 2 of derivative of log function, that is 1 upon, okay. So log of theta minus pi by 2. So this derivative is 1 upon theta minus pi by 2. Multiply derivative of theta minus pi by 2 with respect to theta, that is 1 minus 0. 1 minus 0 divided by derivative of tan theta with respect to theta, that is sec square theta. Okay. So we will find out the derivative of numerator function as well as denominator function. Now we will rewrite this as limit theta tends to pi by 2 of, we know that 1 upon sec square, that is nothing but cos square theta. So 1 upon sec square, that will be cos square theta, that will be numerator, divided by denominator is theta minus pi by 2. Theta minus pi by 2. Okay. So this is the function which we obtained. 1 upon sec square. For this we can write cos square theta and divided by theta minus pi by 2. Now see the form. If you put the value of theta is equal to pi by 2, what will be the form of the function? So this will be in the form. If you put theta is equal to pi by 2, this becomes cos square pi by 2 upon pi by 2 minus pi by 2. Now pi by 2 minus pi by 2 is 0 and cos pi by 2 is also 0. So now this infinity by infinity form is converted into 0 by 0 form. This infinity by infinity, now it is in 0 by 0 form. So if it is in 0 by 0 form, to evaluate the limit, we will apply again L'Hospital rule. So again by using L'Hospital rule, we will take derivative of numerator function and denominator function with respect to theta. So it is d by d theta of cos square theta upon d by d theta of theta minus pi by 2. Differentiate the function with respect to theta. Now derivative of cos square theta, that is 2 cos theta into, by using chain rule, derivative of cos theta is minus sin theta divided by theta minus pi by 2. Its derivative with respect to theta is 1. And in this we will apply the limit theta tends to pi by 2. Put the value of theta equal to pi by 2. So this becomes
0 is the answer.
This becomes 2 into cos pi by 2 minus sin pi by 2 upon 1. Okay. 2 into cos pi by 2 minus sin pi by 2 upon 1. Cos pi by 2 is 0, so 0 into 2 into 1, that is again 0. We get 0 upon 1 value, that is again 0. So limit L is equal to 0 here. L is equal to 0. By putting theta is equal to pi by 2, 2 into sin pi by 2 into cos pi by 2 upon 1. As cos pi by 2 is 0, so 2 into 0 into this 1 divided by 1, that is again 0. So limit is equal to 0. We consider second example. Log of sin 2x upon log of sin x. Limit x tends to 0 of log of sin 2x upon log of sin x. Try to solve this problem. Log of sin 2x upon log of sin x. If you put x is equal to 0, this becomes log of sin 0, log of sin 0 upon log of sin 0. That is, log of 0 is infinity, so this is in infinity by infinity form. Log of sin 0, 2 into 0, 0, divided by log of sin 0. And sin 0 is 0, so this is log of 0 divided by log of 0. That is infinity by infinity. Okay? So this problem is infinity by infinity form. So you can find out the solution of this infinity by infinity form. Try to solve this. And use the link that is given to you for attendance. For your attendance, use the link which is given to you, already given to you on your group. Use that link for attendance of M1. Use the link for attendance. Okay. Yes, what is the answer? Answer. See, if it is infinity by infinity form, we will apply L'Hospital rule, applying limit x tends to 0. Take d by dx of log of sin 2x divided by d by dx of sin x, log of sin x. Now here there are two functions of x, one is log, another is trigonometric function. Answer is 1. Yes, correct. Answer is 1. So here how to find out this? Limit x tends to 0 of derivative of log function, that is 1 upon. Okay. So this is 1 upon sin 2x, derivative of sin 2x, that is cos 2x, and derivative of 2x with respect to x, that is 2, divided by d by dx of log of sin x. So this is 1 upon sin x, derivative of log function, into derivative of sin x, that is cos of x. So this becomes, limit x tends to 0 of 2 is in numerator, cos upon sin, that is cot 2x, divided by cos upon sin, that is cot of x. Now this is 2 cot 2x upon cot x. 1 upon cot is nothing but tan. This 1 upon cot is nothing but tan. So this can be written as 2 into limit x tends to 0 of 1 upon cot is nothing but tan x divided by cot 2x, that is tan 2x. Now to find out this limit, we will multiply numerator by x. This can be written as tan x upon x into x, multiply numerator by x and divided by x. Similarly here, tan 2x, multiply this denominator by 2x and divide it by 2x. Okay. To apply the limit, for tan x, divide this by x, multiply by x. For tan 2x, divide this by 2x, multiply by 2x. Now see here, when we apply the limit for numerator and denominator function, see, this x with x get cancelled, 2 with 2 get cancelled. Separately, you will take the limit of tan x upon x and tan 2x upon 2x. So we know that limit of tan x upon x as x tends to 0 is 1, and limit of tan 2x upon 2x as x tends to 0, that is also 1. So 1 by 1, that is 1. So L is equal to 1. This is the limit for the given problem. Okay. Since limit of this tan x upon x is 1 as x tends to 0, and same way limit of tan 2x upon 2x as x tends to 0, that is also 1. Okay. So given limit is 1. Chandan Kumar, yes. Solved, please execute type question. Okay. E raised to E tan x, E cos x, E sin x. So this is the second form, which is infinity by infinity form. Now we consider next form, that is 0 into infinity form. That is limit of one function is 0, limit of another function is infinity. Nandita, yes. Nandita, can I query? Repeat the last part. What is the last part here? See, we will write this as 2 is constant. Okay. Separating, we will apply the limit for numerator as well as for denominator. Limit x tends to 0, limit x tends to 0. For numerator function, tan x upon x. Only tan x function is there. So for this tan x, we will multiply this by x as well as we will divide for this x. So multiply by x, divide this by x. For tan 2x, multiply and divide by 2x. Multiply this by 2x, divide it by 2x. Okay, this is similar with this. Okay, now see, x with this x get cancelled, 2 with this 2 get cancelled. So what we obtain here? Limit of this function divided by limit of this function. Just like sin x upon x, x tends to 0, limit of tan x upon x as x tends to 0, this is 1. And similarly for this tan 2x upon 2x, limit x tends to 0, this is also 1. So this is 1 upon 1, that is 1. So L is equal to 1, limit is 1. Okay. Yes, yes. First we have to check it is in which form and then we will apply L hospital rule. आपको पहले चेक करना है एग्जांपल कौन से फॉर्म में दिया है और बाद में आपको L hospital rule अप्लाई करना है, whether it is 0 by 0 और infinity by infinity. और दोनों फॉर्म के लिए प्रोसीजर क्या है? सेम ही है. दोनों फॉर्म के लिए एग्जांपल सॉल्व करने की प्रोसीजर सेम ही है. डायरेक्टली यू विल अप्लाई for L hospital rule if it is in 0 by 0 or if it is in infinity by infinity form. Directly you have to apply for L hospital rule. Okay, is it clear, Nandita? Yes. If it is not in that form, then if they are not, then we don't have to solve it forward. Yes. Directly you cannot solve this. Now the next form is 0 into infinity form. Is it clear? The first two forms, 0 by 0 and infinity by infinity form. Hello?
Yes, ma'am.
Yes, ma'am.
Okay. Now we will consider now the next form, that is 0 into infinity form. Third form, that is 0 into infinity form. So for the third form, we will not directly apply the L hospital rule. Okay. See here, See, in the third form, 0 into infinity form, 0 into infinity form, if limit of the function fx as x tends to a is suppose 0, and limit of the second function gx as x tends to a is infinity. Limit of first function is 0, limit of second function is infinity, then limit of their product, that is fx into gx as x tends to a, will take 0 into infinity form. Limit of this function fx is 0 and limit of second function gx is infinity. Therefore, their product is in 0 into infinity form. Okay. So if it is in now, if it is in 0 into infinity form, then we have to write limit of fx upon gx. We will write limit fx upon gx in the form. Limit fx upon gx आपको कैसे लिखना है? fx into gx आपको कैसे लिखना है? Sorry, fx into gx आपको कैसे लिखना है? We will write this fx into gx as if your problem is in 0 into infinity form, then we will write this fx into gx as fx upon 1 upon gx or gx upon 1 upon fx. fx को 1 upon gx, fx into gx को आप ऐसे लिख सकते हो fx divided by 1 by gx or gx divided by 1 by fx, which is suitable. Fx upon 1 upon gx, 1 upon gx divided by 1 upon gx is same as multiply by gx, or divided by 1 by gx is same as multiply by fx, divided by 1 by fx is same as multiply by fx. तो fx into gx को आपको इस तरीके से लिखना है fx upon 1 by gx या फिर gx upon 1 by fx, so that it will get converted into 0 by 0 or infinity by infinity form. इस तरह से लिखने से वो कन्वर्ट हो जाएगा 0 by 0 या फिर infinity by infinity फॉर्म में, और आप इसके बाद एल हॉस्पिटल रूल अप्लाई करके आगे सॉल्व कर सकते हो. ठीक है. So here, if limit of first function is 0, limit of second function is infinity, then limit of their product fx into gx will be in 0 into infinity form. Then how to solve the 0 into infinity? Directly we will not apply the L hospital rule for that. We will convert it into 0 by 0 or infinity by infinity form by writing this function fx into gx as fx upon 1 by gx or gx upon 1 by fx. We will write this function in this form, then it will get converted into 0 by 0 or infinity by infinity form, and then we will apply the L hospital rule. Okay? So we consider the example now.
Hello, ma'am. Hello.
See here, limit x
Type
into
कीजिए
log
ना।
of x, x tends to 0.
Type करना
X into log of x as x tends to 0.
नो तो मैम को कॉल कीजिए.
Limit x into log of x as x tends to 0. How to evaluate this limit? Now see here, if I apply the limit, there are two functions. One function is this fx, second function is gx. So to evaluate the limit, if you apply the limit x tends to 0, so this is 0, and log of 0. Log of 0 is infinity, and this is 0. So this is 0 into infinity form. Given problem is in 0 into infinity form. So here we will apply the limit and check the form. If you apply the limit in the two functions x and log of x is equal to 0, so this becomes 0. And second function log of 0 is infinity. So now the given problem is in 0 into infinity form. Here we will not directly apply L hospital rule by writing the function fx into gx as fx upon 1 by gx or gx upon 1 by fx. Then it will get converted into 0 by 0 or infinity by infinity form. Okay. So here we write this function as limit x tends to 0. We will keep this logarithmic function as it is in numerator. We will write this as log x divided by 1 by x. Divided by 1 by x, that is same as multiply by x. Divide this function log x by 1 upon x, that is same as multiply by x. And when we apply here limit x tends to 0, what will happen? This will be log of 0 divided by 1 by 0. Now log of 0 is infinity and 1 by 0, that is also infinity. So now it is converted into infinity by infinity form. Okay. See here, 0 into infinity form directly cannot be solved by using L'Hospital rule. So we write this function fx into gx as fx upon 1 by gx or gx upon 1 by x. So we will keep this logarithmic function in numerator. We will adjust this multiply by x, that is same as divide by 1 by x. So we write this log x divided by 1 upon x. Now, if you put the limit x is equal to 0, this become log of 0 and divided by 1 by 0. 1 by 0 is infinity and log 0 is also infinity. So now it is converted into infinity by infinity form. Madam, infinity form first explain kariye. Infinity form. वही है इंफिनिटी बाय इंफिनिटी अभी किया था ना पहले दो एग्जांपल इसके पहले जो एग्जांपल लिए थे वो इंफिनिटी बाय इंफिनिटी फॉर्म की है इंफिनिटी बाय इंफिनिटी या फिर 0 बाय 0 हां दोनों में से कोई भी फॉर्म में आपको मिल जाएगा 0 into इंफिनिटी कन्वर्ट इनटू इंफिनिटी बाय इंफिनिटी और 0 बाय 0 फॉर्म ठीक है तो ये होगा आपका इंफिनिटी बाय इंफिनिटी फॉर्म एंड नाउ यू कैन अप्लाई L'Hospital rule. So now we will apply L'Hospital rule. According to the L'Hospital rule, we have to take derivative of numerator function. So derivative of numerator function, that is log x, and derivative of denominator function, that is 1 by x. Derivative of log x function, derivative of denominator function, that is 1 by x. Okay, so here this is equal to limit x tends to 0. Now what is derivative of log of x? That is 1 by x. And derivative of 1 by x, that is minus 1 by x square. Now see here, limit x tends to 0. This is 1 by x. And divide by minus 1 by x, that is same as multiply by minus x square by 1. Now this x with x get cancelled. So if you here minus 1 is constant, if you apply the limit x tends to 0 in this function x, so this becomes minus 1 into 0, that is 0. So limit n is equal to 0 here. Okay, very simple problem. Derivative of log x 1 by x, derivative of 1 by x minus 1 by x square. 1x with this x get cancelled, we get limit of minus x as x tends to 0, minus 1 is constant, x is 0, so answer is 0. Limit n is 0 here. Okay. Now in the same way, you can solve this second example. सेवन फॉर्म में सेम प्रोसेस नहीं है, थोड़ा अलग प्रोसेस है.
एक टाइम झाला ना.
First example of 0 into infinity form. Now we will solve the next problem of 0 into infinity form. Limit x tends to 0.
मॅम ला सांगा ना. किती टाइम झाला?
X tends to 0 of sin x into log of x.
अबे मैसेज कर ना.
अभी देखो यहाँ पे limit apply करो. When we apply the limit,
वे मैसेज करो.
sin 0 into log of 0. Sin 0
हाँ मैसेज करो सब जन टाइम ओवर हो गया.
into log of 0 है infinity.
मैं ज्यादा पढ़ लूंगी क्या?
The problem is in 0 into infinity form. Given example is in 0 into infinity form. तो 0 into infinity form में हमने आइडेंटिफाई कर लिया है फॉर्म, तो ये डायरेक्टली सॉल्व नहीं होगा, इसको हमें एडजस्ट करना है. ओके, यस, just in just 5 minutes we will solve the example. मुझे पता है टाइम हो गया है, हाँ यश टाइम हो गया है मुझे पता है, ठीक है। So here we will not solve directly this problem. We convert the 0 into infinity form, either in 0 by 0 or infinity by infinity form. तो कैसे करना है? Limit x tends to 0. In generally अगर log का function है तो आपको log का function numerator पे ही रखना है. Keep the function logarithm in numerator. Shift the second function in denominator. ठीक है? तो हम log function numerator में रखेंगे log x. और ये sin x को कैसे लिखेंगे? 1 upon sin x, ठीक है? log x divided by 1 by sin x. तो अभी देखो, if you apply the limit, this become log of 0 और ये हो गया 1 upon sin 0. 1 upon sin 0 is 0 और log 0 क्या है? Infinity और 1 by 0 क्या है? Infinity. So now it is converted into infinity by infinity form. ठीक? So we can write this as limit x tends to 0 of log of x, and 1 upon sin x is nothing but cosec x. So if it is now infinity by infinity form, we will apply L'Hospital rule. Okay. And according to L'Hospital rule, we have to take derivative of this log x function as well as derivative of this denominator function with respect to x. So you will take the derivative of log function, numerator function and denominator function with respect to x. So what we obtain here? Derivative of log x function. So this is d by dx of, directly we will go for limit x tends to 0. Derivative of this log of x, that is 1 by x. And derivative of this cosec x, that is minus cosec x into cot x. Minus cosec x into cot of x. This is the derivative. So this is limit x tends to 0. This can be written as 1 upon x into cot x is nothing but 1 upon cot x is nothing but tan x, and 1 upon cosec is nothing but cos of x. Okay. Sin, sorry, it is sin x. 1 upon cosec. Sin x should be numerator function. Sin x. Okay. 1 upon x as it is with minus sign, minus 1 upon x. 1 upon cot is nothing but tan, and 1 upon cosec is nothing but sin. So tan can be written as sin upon cos. Tan can be written as sin upon cos. So this limit x tends to 0 of minus multiply by sin into sin, that becomes sin square x divided by cos of x. And now if you apply the limit, x tends to 0. So this becomes sin 0. Sin 0 is 0, but cos 0 is 1. The form of the limit. 0 form is infinity. But it is x. So it is x into cos of x. Sin square upon x into cos of x. So if you apply the limit here, then it is sin 0 is 0 and cos 0 is 1, but x is there. So 0 into 1, 0. So now it is in 0 by 0 form. So if it is in 0 by 0 form, yes, 0 by 0 form से होगा. So you can solve this by using L'Hospital rule. फिर से आपको क्या करना है? इसका डेरिवेटिव लेना है, इसका डेरिवेटिव लेना है, और लिमिट पुट करना है, ठीक है? So find out the limit of numerator function and denominator function. So this is minus sin outside the bracket, derivative of this sin square x, that is 2 sin x, into derivative of sin x, that is cos x. And for this derivative, you will apply product rule, UV rule. Again, u into v dash, that is x into derivative of cos x minus sin x, plus v into u dash cos x into derivative of x with respect to x. यहाँ पे limit apply करो, limit x tends to 0. See what will happen? Sin 0 is 0, cos 0 is 1. So this is 0 in numerator. This is 0, cos of 0 is 1. 0 divided by 1, that is again 0. So limit is 0 here. Okay? So in this way we can find out the limit in 0 into infinity form. Directly 0 into infinity, that cannot be solved. So here we have to convert that into infinity by infinity form or into 0 by 0 form first. and then by using A hospital, you can evaluate the limit. Okay. So is it clear? So now we will stop here, and in the next lecture we will consider